Today we're going to be multiplying decimals. Our goal is to build models and use a standard algorithm to multiply decimals. Let's review some important vocabulary. So, decimals have what's known as placeholders. So, placeholders are zeros that you can have at the end of decimals. For example, I can have a 0 at the end of each of these. And a decimal point exists in a whole number, but it can also be dropped. So for example, in a number like 37, I can have a decimal and a 0 at the end, but I can also drop that and it will still maintain the same value. A 0 can be dropped at the end of a decimal without changing its value as well. Now, what is important to note is if you have a number like 600ths, this 0 is important and it cannot be dropped. For example, some students will often, because they forget certain information, think that 600ths is the same as 6/10. And we, of course, can often associate decimals. I encourage you to think of them as money. Well, think of it as 6 cents versus 60 cents. So the value is not the same. So when it is in the beginning of another number, it does matter. It's not just a placeholder that can be dropped. When it's only at the end of numbers, that's when we can drop that 0. So that's a little review. A common mistake is, of course, students will misplace the decimal. They won't know where exactly to put a decimal in a certain number. So always ask yourself, especially at the very end of a multiplication problem, where does the decimal go? So first we're going to look at it using a standard algorithm in order to find the product. So the first step, of course, that we want to do is to estimate the product. So we can, of course, round 32 and 5/500ths to 32. And I can round 2700ths to 1/4 or 2500ths. And then I can just ask myself, well, what is 1/4 of 32? In other words, 32 divided by 4, which I know is 8. So I know that my answer should be close to 8. So now we're going to multiply this to find an exact answer, which I know is going to be close to 8, by multiplying. And before, we always will multiply ignoring the decimal with multiplication. Now remember, it's not the same rules with addition and subtraction or division, but we ignore the decimal at the beginning of multiplication. Of course, I always have to check to see how many decimal places there are at the end. And I can see there's 2 at the top and 2 at the bottom. And you can always use tally marks, but I always like to make a little mental note for myself. Then you just multiply as usual. 5 times 7, 35. 7 times 0 plus 3 is 3. 7 times 2 is 14, carry the 1. And 7 times 3 is 21, plus 1 is 22. Then I'm going to hold my spot with a 0 or an X when I multiply my tenths place. So then I have 2 times 5, which is 10. 2 times 0 plus 1, 1. 2 times 2 is 4, and 2 times 3 is 6. Now I can add my results together. 5, 3, 5, 6, and 8. And what you need to ask yourself at the end, now that you've done all your multiplication, double check to see if it's correct, notice I have 86,535. Well, I know that my answer when I estimated should be kind of close to around 8. So it can kind of help you when checking to say how many decimal places should I move? Well, I always have to then count up however many decimals I have on the top and the bottom. So I have 2 places after the 1, 1, 2, on the top. And I have 2 places on the bottom. Another common mistake is students will only look at one of them, or they'll align the decimals like in addition and subtraction. So what you need to do is then count, okay, I have 2 on the top, 2 on the bottom, so that means I have to move a grand total of 4 decimal places at the end of my answer. Now, I have a decimal. I am always going to start at the very end, and then I'm going to go to the left 4 places. 1, 2, 3, 4. That's going to give me 8 and 6,535 ten thousandths. And I can double check to see, well, does my answer look similar to 8? Well, I know that I rounded down in both cases, so it should be a little bit more than 8. And I can see that, yes, my answer makes sense. So that's using the standard algorithm. Little review. So we're all familiar with our base 10 blocks. And of course we have our flats, our rods, and our units, of course representing hundreds, tens, and ones. So in this case, we're going to use it a little bit differently. Flats are going to represent 1 whole. Rods are going to represent the tenths place, so that would mean that there's a decimal. And then our units are going to be the hundredths place. And that can help us when building models for multiplication. And of course, it is always acceptable to write them out as squares, longer rectangles, and smaller units. So looking at our example that we have in front of us here, we can see that if we were using the base 10 blocks, we would see that we have 0 wholes, 3 tenths, and 7 hundredths. So this would be 0 and 37 hundredths as my model. So even when multiplying with models, another important step, of course, is to always estimate the product to make sure that your answer is going to make sense. So we can look at a number like 2.6 or 2 and 6 tenths, and we can say that that is close to a familiar number that's easy to multiply, like 2.5 or 2 and 5 tenths. And we can, of course, say that 1 and 3 tenths is close to 1. And when I multiply that together, of course, I get 2 and 5 tenths using the standard algorithm. So now I know that my answer should be a little bit more than 2.5 or 2 and 5 tenths, because both of the numbers I'm dealing with are slightly more. But if I get a number like 5, I know it's probably a mistake that I've made somewhere, maybe in my place value. So that's a really good starting point. So here I can now, of course, use models to multiply 2 and 6 tenths and 1 and 3 tenths. So what I always want to start with is my product box. And the product box is basically where all of my numbers and all of my symbols are going to wind up. So first I'm going to model 2 and 6 tenths. So that gives me my rectangles and 6 tenths. So those are my 2 wholes, and then I need, of course, 1, 2, 3, 4, 5, and 6 tenths to go with that. So on the other side, I'm going to have my 1 and 3 tenths. So that gives me 1 whole and 3 tenths. Now, of course, these drawings that I've drawn are not proportional, but it can give me an idea of what happens when I multiply the 2 numbers together. So now that I've built these models, now I can just calculate the different areas. So I can first start with my 6 tenths and 3 tenths, and I notice that I get here 18 hundredths, which I've labeled 3 tenths and 6 tenths is 18 hundredths for you. Then I can go ahead and look at my second units of measurements, which I can of course see is 1 times 6 tenths, which gives me 6 tenths, because I can count them up and see that these of course represent my tenths. Now I can of course look at my next group, which I can count up is of course 2 times 3 tenths, which gives me 6 tenths. 1, 2, 3, 4, 5, 6. Then of course I can represent visually 1 times 2, which of course is 1, 2 wholes. So now I have all of my totals and I can really just add them all together. So I have 2 wholes, and I have 6/10, or I can word it as 6/10 plus another 6/10 and another 18/100. And then I can just add all my totals together. You can do this, of course, by counting them up, or you can take your totals and align them. Of course, when we add, we align the decimals as needed. And I might, of course, align a little bit better. I can fill in my empty spots with zeros, and I can add all of my totals together. So just to look back at the previous page, I can see where everything's aligned. And now, of course, I have 8/100, 13/10, and I can bring down the decimal, and 3/10. So when I multiply 2 and 6/10 times 1 and 3/10, that gives me 3 and 38/100. And I can double check, is that a little bit more than 2.5, which was my estimate? And I, of course, can also check my drawings. I have 2 holes here, and then once I get up to 10/10, of course, that gives me 1 hole. So, of course, that's 2 plus 1. And then once I get, of course, 10/100, that gives me 1 bar, or 1/10. So that's how we can multiply decimals with models. Now I want you to try your own problem. So in this guided practice, I want you to use a model to multiply 6 and 4/10 times 1 and 7/10. And I want you to check your answer by estimating, and I also want you to check your answer by using the standard algorithm. So I should see one answer using multiplication, showing your work using the standard algorithm, and then another verifying it with the model. Go ahead and take a minute to pause this tutorial, copy down the problem, and try it out on your own. Another excellent review in multiplication of decimals. Remember to use the standard algorithm when you need to, but also remember to use models to show why problems work the way they do. And make sure you thank your old teachers for giving you a strong mathematical foundation in multiplying decimals. Another good job today.